initialized this. We have not yet initialized. So instead of initializing with the object reference, okay, instead of initializing by just creating an object and with the help of object reference, instead of doing like this, suppose if you are creating an object for the student, it will be student yes is equal to new student of no argument constructor. Now here, okay, now here, what we have to do is very simple. In the student, one second, guys. Excuse me, yeah. What is this? Ma'am, is this initializer is only used for this code is only for initializers, guys. Hold on. Let me finish completely, okay? So have some patience. So here, now we have created a student object, okay? Now we have created a student object. Now after creating student object, usually what you will do? Yes dot name is equal to one name, Kumar you will take. Okay? Now here, yes dot id is equal to whatever 22 you will take id 22. Yes dot contact number is equal to one seven 10 numbers 1 2 3 4 5 6 7 8 9 10 some 10 numbers. So you have to give the long data type L so that it will indicate that it is for the variable, it is for the one second, excuse me. Excuse me, guys, one second. Excuse me, guys. Yeah. So here what we are doing here, we are initializing, okay, we are initializing the attributes here. We are initializing the attributes, and as we are initializing the attributes here, okay, we can also print them. We can also print them, okay. So within the println statement also you can mention here, and the same thing you'll be seeing in your output, okay. This is fine, okay, this is fine. So SYSO, we'll just go for s dot sid, s dot sid. Next, if you want to print the contact number, if you want to print the contact number, you can go for println statement. Now if you execute, you will be getting, okay, you will be getting the data mar22 and all this data for this phone number, okay. Now this is fine, this is what we have done in yesterday's class also. But here, instead of doing like this, see, for every object, if you create one more object, again you have to initialize, if you create third object, again you have to initialize, if you create fourth object, again you have to initialize. So again instead of initializing like this, okay, again you have to call, you have to initialize. Instead of doing like this, okay, instead of doing like this, we can go for having these all these statements, okay, having these all the statements inside this student details, inside the student details. Instead of yes, okay, we don't know which object will be calling, okay, which object might be calling this method, we don't know, okay, we can create any number of student objects. but here but here now currently what's happening is, okay, currently what's happening is, we will be using your this keyword. What for? This keyword will, it's a non-static variable, it will store the reference of currently executing object. So any object can call this method, okay, any object can call this method, so that this method will be initializing that object's data, okay. So when you're going for this dot name is equal to Kumar, this dot name is equal to Kumar, if you're taking like this, See, Kumar is a data we have given, but from the user, if you want to take, means whatever the local variable you have taken here, no, you have to have the same local variable here. Next, this dot id is equal to this id. Okay, this id. So here you will be taking this id. Okay, now this dot contact number is equal to contact number. You could have told, ma'am, we can take the same variable. No, this name variable is this name variable. This ID is this ID, and this contact number is this contact number. This contact number. So here what we have taken is through the method we will give the data. To the method call statement here will not give for every individual object we have to print like this. So avoiding this, we'll just call the student details method, and for every objects data, see every student s is equal to new student of no argument constructor, which means one student object is already created. Obviously it will have a constructor, it will be loading all these members, and to these members you have to give some data. How you can give? By using this dot name is equal to name, this dot IC is equal to ID, this dot contact number is equal to contact number. Just you can mention this. Okay, now currently which object is executing? Yes. Okay, so if we call s dot student details method, s dot student details method, here we can give the data. We can give Kumar. Okay, and we can give ID, we can give phone number 1 2 3 4 5 6 7 8 9 10. Okay, now so what did we just do here? Just with the help of the reference variable of the student, we called the student details method. We called the student details method. Okay, by using the method call statement, by using a method call statement, and also we are passing the data here. We are passing the data here. See, without this also we can do this. Suppose that we remove this keyword. Let me remove this keyword. Okay, and here I'll just write it as a name. Okay, all capital I will write here. Let me write it as a name, then ID, then contact number. Okay, so what will I give here is name is equal to name variable. Okay, ID is equal to ID, contact number is equal to contact number. So here still it will be initialized. See what we are giving here using method call statement. Okay, using method call statement, here we are passing the data. Here we are passing the data, and whatever, see, Kumar is going and storing inside the name variable. 22 is going and storing in a ID variable. Number is going and storing in a contact number variable. Those variable have been initialized to the original attributes, that is name, ID, and contact number. These are non-static variables. These are name, ID, and contact number. As we can see here, these are the original data. Okay, I mean original variable. Now for this variable, we are initializing with a variable name. I mean the ID and the contact number. You see, Kumar 22 and the number have been initialized there. Into the name we have Kumar. Into the ID we have 22, and into the contact number we have the phone number. Okay. Now what are we doing here? Into the name we stored Kumar, no, because inside the name what is there? Kumar is there. Now inside the ID what is there? 22 is there. Inside the contact number what is there? All the numbers is there. So the name is the same name variable. This ID is this ID, and the contact number is this contact number. Okay, here what we are doing here, to the original variable, okay, we are providing a local variable, and we are initializing it. For the original variable, that is non-static variable, we are providing a local variable through which we are passing the data from the method call statement. From the method call statement, we are passing the data, and it's going inside the name variable, ID, and a contact number. Name variable, ID, and a contact number. This is all is happening. Now let us execute this. So you'll be getting the same data. Okay, you'll be getting same data here. Are you getting comma 22 and all these digits? Yes, you are getting. So sometimes what happens when you're creating any method or constructor, by default you're creating, no, what happens is this name variable and this original name variable will come same. This name variable and whatever the variable is there here, no, it will have the same name. The global variables, whatever the name they will have, no, local variables will also have the same name. Suppose if you have for the name attribute, if you have the name like this, name, and for the id it is id, the contact number it is contact number. Okay, and here let us initialize here also. Name is equal to name, id is equal to id, contact number is equal to contact number. Okay, here what's happening? Here what's happening? The data is going through the student details method called statement. It is this method has been called, and the data is going to name, ID, and contact number. It is going, and it is reinitializing to itself. It is reinitializing to itself. Are you guys getting here? Are you guys getting here? Here it is. Here it is reinitializing itself. Here it is reinitializing itself. Okay, it is reinitializing itself. So to avoid reinitializing itself, okay, I'll show you the proof here. You'll not get any output here now. Okay, what are we? Okay, so since we are printing the same, okay. So here what happened, if you're printing this dot, if you're printing this original name variable, here you will not get any data inside the original variable. So let me print the original data now. Original, that is yes dot name. Okay, now let me execute here. Okay, so in the s dot name, what we are getting here? Null. Why are we getting null? We have already initialized, no? We already initialized, no? No, we didn't initialize the original attributes. We didn't initialize the original attributes. Instead, what we have done? Here we have a constructor. Okay, here we have a constructor and the data name, ID, and contact number. We are reinitializing the same data again. Okay, same variable again we are reinitializing. So to avoid this, to take this into consideration, we'll be using this keyword, this dot name, this dot ID, this dot contact number. So now the data will go and store whatever through the local variables, whatever data we have taken from the method call statement, whatever the data we have taken from the method call statement, it has been initialized. It has been initialized to the original attributes. Now if you call s dot name, s dot id, and s dot contact number, you will be getting all the data here. Okay, I will call one s dot name. Now you will be getting the name Kumar. Now you'll be getting a name Kumar. Why? Why you'll be getting a name Kumar? Because the original data has been initialized. No, original data has been initialized. This keywords holds the address of currently executing object. This keyword holds the address of currently executing object. Okay, currently executing object address. This keyword will store. See, now we have created one object. Student test is equal to s dot student details of data we have passed. Okay, data we have passed. Now, let us create one more student object. Student S1 is equal to new student of no argument constructor. Now, when we call S1 dot student details method, okay, now here we'll give one more name, Kumari, and we'll give 22, and we'll give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers we are giving. So from here, now what will happen is, first of all, when this object is executing, when this line is executing, control will be currently present in this attribute, this variable it will be, and there is an address stored in this variable. Now yes dot student details method, if you're calling, okay, student details method, control will go to this student details method, and whatever the data you have passed here, no, Kumar 22 and the phone number, it will go and it will store in this local variable. It will go and store in this local variable, and this local variable data will be initialized to global data. Okay, the global data member, that is variable non-static. Okay, so whatever the data you are passing through the method formal arguments, whatever data you are taking from the method call statement, that will be initialized. Okay, that will be initialized here. Okay, so currently here inside this dot name you have the name Kumar. Currently we are executing student test. No, here now we in the name we have Kumar. In the ID we have 22. In the contact number we have 789. this phone number. Okay, next this student S1 object. Student S1 object is getting executed. Now S1 dot student details method. First data we can go for Kumari here. This dot name is Kumari. This dot ID means 22. This dot number contact number means starting from 874. Okay, this number. So like this, you can create n number of objects and you can still access the student details method, wherein student details method will give a initialization for the attributes. It will initialize the data. The student details method, now it will initialize the data. It will initialize the data. Just you can call this method, you can initialize also and you can print also. These are the uses of calling this non-static method by passing the data, okay, using local variables in the formal arguments. And here also we are printing the data after, not after storing, we are also printing it. So this is how you'll be using your this keyword. This is how we'll be using your this keyword, using this keyword. Okay, did you guys get an idea about this keyword now? Did you guys get an idea? Okay, let me execute and show you here. One more from start, ma'am. Okay, sure. We will trace this code. It's very easy. We will trace this code. I think then you'll understand this. Okay. So what are you seeing now? You're seeing Kumar data, Kumar 22 and phone number. But you're seeing Kumari data also, Kumari 22 and all this data, I mean phone number you're seeing. How come using same method we are getting different data? Well, how comes with using same method we are getting different data? We are getting different data because first time this yes object is executing, and whatever we have data we have sent, it went and stored using this keyword. It went and stored inside this original attributes. But later using the second object, we are giving the data again. We are calling that method again. We are giving the different data. So this dot name, this dot ID, contact number, everything has changed into the original attributes. Okay, so this is how you'll be doing it. And now let us start tracing this code. It's very easy and you'll get to know. Just a minute. So here let us create a memory. Our memory is let us write it a little bigger. Okay, so our memory okay, address. Okay, first let us go for methods, memories here. Okay, method area, class static area. Okay, stack area and heap area. Stack area as well as a heap area. So let us write the name of the memory, that is Java runtime memory. Java runtime memory. And during class loading process, we can go for a different memories here, that is method area, class static area, stack area, and heap area. And a heap area. So here what we will do is very simple. First and the foremost thing is you have to load the whole class inside this class static area. You have to load the whole class inside the class static area. You have to load. Okay, that is the first thing. And now we will have the class name here. So class name we have given as a student. So class student will be there here, student. Now next, what all the methods we have, it will be loaded here. So currently we have two methods. That is a student details method as well as one main method. Okay. So just a minute. Let's take it a little bigger here. Okay. Okay, now what we're gonna do is very simple. We'll be writing the address and the method signature of both the methods. So here the method signature is student details method. Address is 0x1. We have the instructions. Those are system.out.println of this dot name is equal to name. System.out.println of this dot id is equal to id. System.out.println of this dot contact number is equal to contact number. So id cannot be same. So let us change it to 23 here. Okay, so next we will go for your one more method, that is main method, that is 0x2. Main method signature is main string array arguments. Now let us have the instructions here. The instructions are student S1 is equal to new student of. New student of, here we have given data Kumar 22 and the phone number we have given as 1. Okay, L. Okay, so we are done with the one object. So let us take one more object, that is student S2. Student S2 is equal to new student of. Okay, new student of. So you have to give Kumari here. Kumari, 1 second guys, excuse me. Excuse me guys, yeah. So next what we have to do is we have to go for the data here, that is Kumari and the number 23 and the phone number whatever, 1 2 3 4 5 6 7 8 9 10 L. Okay, now and now here, so here we have two methods. Okay, one is a non-static and one is static. One is non-static and one is static. Listen carefully. Now one frame will be created here. Okay, and we will have a tabular column for the frame. Now let us go for method signature and address here. Okay, we will be writing method signature here, method signature, and here you will be writing address. We'll be writing the address. See, we have main method only static here. Okay, static method is only main method. So we'll go for main string array arguments. Okay, so address will be 0x2. That's it. That's all is our class loading. That's all is our class loading. So next what we will do here is very simple. JVM will call main method. Your JVM will call the main method. JVM will call the main method. So whenever a main method is called, okay, whenever a main method is called, one frame for main method will be created. One frame for main method will be created. A frame for main method will be created, and so after the main method is called, one frame for main method will be created, and the frame number is F0. For the main method, we'll go for main string array arguments. String array arguments. Now here inside the main method, now the first instruction executes. Excuse me. The first object executes, that is student. S1 is equal to new student of no argument constructor. As soon as we go for new keyword, the new keyword, as soon as new keyword executes, there will be one frame created for that. There will be one frame created or one object, one memory created only for that object. There will be a memory created only for that object. Okay. Now the address for that object is, you can take it as a 0y1. Okay. 0y1. Next. New keyword will call the student of no argument constructor. Okay. Student constructor, no argument student constructor, it will call. Whenever student constructor is called, first and the foremost thing it will do is, it will load all the non-static members. It will load all the non-static members. Okay. So non-static members, you can take up variables, like the variable that is name, it will get stored here. Name will get stored. Okay. With the default value, initially it will get stored. Okay. It will get stored with the default values. ID will get also stored with the default value 0, and the contact number will be stored with the default value 0L. Okay. Now what happens after student constructor is called? Now one more method is there. Okay. One method is there. So let us call that method also. So the method will be called with the help of a method signature. It will be called with the help of method signature and the address. Okay, here we'll have the method signature as well as the address of that method here. Okay, so let us go for the method signature here. Method signature, and we'll go for address. Now method signature is, okay, we'll go for method signature, and in the method signature, now if you can see here, which is the only non-static method we have? Here it is, student details method. Okay, student details method is only non-static method. So let us load them. Student details method. Student details method. Address is 0x1. So constructor work is done. Constructor work is done. After that, constructor will tell new keyword work is done, and new keyword will take the address of the object which has been created, and it will give to the S1 variable S1. So inside the variable S1, now we have the data or address 0y1. We have S1, inside S1 we have 0y1. We have 0y1. Next, after this, what will happen? We have called a method that is, okay, we have created S1. Okay, let us write it as only S. Okay, now let us create call the method that is S dot student details method. Student details method. So student details method, the first data you can get it as a Kumar. Okay, you'll get it as a Kumar. Next 22, and the number starting from 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let us check here. Whatever the data we have given, let us fill the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. L. Okay. So what we have done just now, what we have done here, we have called a method. And we have passed the data. When we have called a method, the control will pass the execution of the main method, and it will go to called method. So for the called method, one frame will be created. One frame will be created for the called method, and here now what happens is, so called method name is student details method. Student details method. Okay, and it will have the data that is student name, student ID, and student contact number. Name, ID, and contact number. So the Kumar will go and store in name, and 22 will go and store in ID, and contact number will be stored in the C. Okay, let me write in words only. Hope this space is enough. Name, ID, contact number. Okay, this is a method call statement, and this has from the main method the method has been called, so it will come to the called method. And now the instruction executes. Now the instructions execute, that is system dot out dot print ln of this dot name variable is equal to name. So when this happens, what will happen is this dot name is what is stored in this keyword. This keyword will store the currently executing object address. Which is the currently executing object? Student S. Student S is the currently executing object. So address 0y1 is stored in this keyword. Inside this keyword, we have the address 0y1 now. Now 0y1 dot name is what? 0y1 dot name. 0y1 dot name. So you will be accessing this name. 0y1 dot id. 0y1 dot contact number. 0y1 dot student details method. Okay, so like this, with the help of the object reference, okay, with the help of the object reference, you can easily access the attribute. So this dot name means this name variable. So into the name what we have passed? Kumar. Into the name what we have passed? Kumar. So here into the name we have passed Kumar. Okay, and into the id we have passed 22, and into the contact number we have passed the number which start from 703. Okay, now currently the name variable is this local variable. Are you guys understanding? This name variable is this variable. This dot name means this variable. This dot name means this variable. Okay, so this dot name variable is equal to name variable. So currently Kumar has been stored inside name variable, so that data will come and store in this dot name. Okay, so into the name variable, local variable name, we are passing Kumar from the method call statement, and that Kumar will come and store inside the local variable, and the local variable has been initialized to global variable, and the local variable has been initialized to global variable. Okay, so this is how now currently inside the name variable you will not have null, you will have Kumar. Okay, next we shall go for the id, and parallelly we are also printing it. Okay, parallelly we are also printing it, so the output first output will be Kumar. Next, after this, next, so let us go to next instruction, that is system dot out dot println of this dot id is equal to id. So id is a local variable. This dot id means this id. This dot id means this id. So this means what? 0y1. This means what? Address 0y1. This dot id means 0y1 dot id, which means this variable. Okay. So this dot id is equal to id. What are we passing inside the id here? Inside the id we are passing 22. Inside the id we are passing 22. So here instead of 0, now it will be 22, and the same data will be printed in the output, because both we are doing initialization also and we are printing also. Okay, next. So after this, let us go for the last instruction inside here. That is system dot out dot println of this dot contact number is equal to contact number. Now this dot contact number is this contact number. This dot contact number means this contact number, and this contact number is the data which you have passed through the local variable which has passed, and it is now initializing the global attribute. It is now initializing the global attribute. Okay, now this dot contact number means this contact number, and you will have the number 70340567110, just a random number. So our output will be 70340567110. Okay, so this will be our output. Now after that, everything got executed. So after that, okay, you will be removing this whole memory. Why? Because execution is done. Since the execution is done, now the memory or the method given, method which has been, control went to that method. No, now that control will go back to the calling method. Now that control will be going back to the calling method. So calling method execution is done. Now it will go for the next instruction. Next instruction is student s1 is equal to new student of no argument constructor, and s1 dot student details of. Student details of. Now here at the starting we have given name Kumari. Let us write the name here, that is Kumari. And the age we have given 23 and the phone number we have given as 1 2 3 1 second 1 2 3 4 5 6 7 8 9 10 L. Okay, so here we have L here. Okay, so this is about a okay, phone number we have taken. So now what happens, you already know. First line, when student S1 is equal to new student is executing, because of this new keyword, okay, one object will be created. Because of this new keyword, one object will be created, and we will take it here itself. Because of the new keyword, the object will be created, and now into the object, okay, into the object, now let us store the data. Okay, let us store the data here. Okay, the object address you can take it as a 0y2. Okay, 0y2 we can take it as a 0y2. And next what will happen is, so new keyword will call the student of no argument constructor. Now when it is called, obviously name will be loaded, it will have null, id will be loaded, it will be having 0, and contact number also will be loaded, it will have 0L. Now method also will be loaded, method with the method signature and address will be loaded here. Okay, so let us go for method signature here. Method signature and the address. So the method is, that is student details method. Student details method. Address is 0x1. Now method everything got loaded, and new keyword will give the address to S1. So inside S1 we have the data or the address, that is 0y2. We have the data 0y2. We have the data 0y2 inside the second object, that is S1. Now after that there is a method called statement. So S1 is equal to, S1 dot student details method. So one frame will be created. We forgot to name this F1. Okay, so one frame will be created now. Now what happens is, okay, one frame will be created for the called method. One frame will be created for the called method. So after that here, now the method name is student details method. Student details method, and we have a name, ID, and a contact number. Now here the frame number you can take it as a F1, because there is no F1 currently, only F0 is there, then F1 is there. Okay, next let us initialize system.out.println of this dot name is equal to name variable. Now currently into this name what we are giving, into this name currently we are passing Kumari, ID 23, phone number starting from 80. Okay, now this dot name is equal to name means 0y1 dot name is equal to whatever the data we have given, that is, instead of null it will be Kumari. Now next system.out.println of this dot id is equal to id. Now when this dot id is equal to id, instead of 0 we'll be going for 23. Next system.out.println of this dot contact number is equal to contact number. Once again, Excuse me, guys. Okay. So here, what happened? So ID is done. No, contact number is done. I mean, contact number we have to write. So contact number we can take it as instead of this data, instead of default value, you will be getting a contact number 8023456791. So what's happening here? We are storing it. We are reinitializing as well as we are storing it and we are printing it. That is Kumari will be printed, 23 will be printed, and the data is to okay. This phone number will be printed. Okay, because we are initializing and parallelly we are printing also. Okay, now the frame will be removed because execution will be done. Execution is done, so the frame will be removed. Now control will go back to the calling method. Control will go back to the calling method. So after that, do we have anything else left here? Do we have anything else left for the execution? Obviously, no. So the whole frame will be removed now. The whole frame will be removed now, and the control will be the control will be removing the whole memory. The whole memory will be removed from the execution and it will be given back to the RAM. Okay, and your output will be Kumar 22, phone number Kumari 23, and phone number. Okay, so this is the tracing part of your code. This is the tracing part of your code, and this is how we trace it. Okay, this is how we do trace it. Okay, so what happened? We have stored. Okay, one time only we stored the student data as main method, and we have created a student tabular column here where we will go for method signature and address of the static members. Now JVM calls main method starts executing. As soon as the new keyword is created, one object is created and respectively methods are executed. And another method also, another object is also got created here, and obviously the method also got executed. And this is how we will be getting this data. This is how we'll be getting this data. And this is how this keyword will be behaving. This is how this keyword will be behaving. Okay. So I hope you guys have understood. Everybody understood? Did you guys get the concept? This same output we can also. What is the need of using this method? You will come to know next. You'll come to know. This will be using in constructor. No, that time you'll come to know. So we are having this inside a method now. Currently we are having this inside a method, but inside a constructor also you will have this. And having this inside a method here is okay. See, just we can here we are reducing the code also. Okay, these are the benefits. You are reducing the code just by calling this method. Okay, earlier what we have done, we have created method, we have printed, but only attributes we have printed. We have just initialized name is equal to data we have given. But if you create one method like this, and you can call you can create n number of objects, and you can call these methods and you can initialize the data. You don't have to initialize for every object. You don't have to create one method. You don't have to initialize for every data again and again. Just call that method, pass the data. That's it. It will be initialized. Just call the student details method and you give the data, and respectively it will see which object is currently getting executed. If student S is currently getting executed, it will reinitialize student S data. Okay, it will be initializing for the attributes of student S. But if student S1 is executing, now it will be initializing the whatever the given data into the student S1 object, attributes. Okay, so these are the uses of your this keyword inside here, this keyword. Okay, yes, Himanshu, got it? Yes, man, did you get it? Okay, your counselor also came. Okay, and did you guys, everyone understood the concept of this keyword? What for we will use? This is a keyword, and we'll use it for storing the currently executing object address. And using this, we can access the variable, and you can have it for the initialization also. Okay, so guys, everybody understood. Only 2 people are responding. What about others? Did you guys understand the tracing part? If you understood tracing part, you understood concept. Okay, if you understood tracing part, that's enough. Okay, guys. See, there is a point why we have to use this keyword. See here, instead of writing so much code, okay, instead of writing so much code, we can just write this method. We can just write this method, okay, and just call this method. See, just create object, okay, call this method by passing the data. You will be doing two works here. You will be passing the data, you will be initializing to the original attributes, as well as you will be printing also, okay. So to initialize, we'll be using this keyword, okay. This keyword is used to initialize, okay, and this keyword will store the currently executing object address, okay. So this is how your this keyword works. Now let us go, okay, let us take a snap of this first so that we'll not miss this. Let us execute this. Okay, let us take a snap. Let us take a snap of the tracing part also so that you can trace it later. Once again, where is it? Okay, yeah. Let's take a snap of this tracing part. Output you already have. Until here, I think it's enough for you. Okay. Okay, guys. Now let us go for your next member. See, we have studied about. Ma'am, means object reference is there na using this keyword. They are now using this keyword. See, object reference is a local variable. See here, object reference is a local variable. Object reference is stored in a variable S. This is a local variable. Using local variable, you are passing. I mean, you are calling a method, you are passing the data. Now, how come you are telling only that object? Okay, you are calling that details. Okay, can you pass the date? I mean, address also. This address, can you pass here? Can you pass the address here? Is it possible? No. And only for this object only, okay, a number of objects can be, you can tell, I want to execute only for this object. Now, how can you tell only for this student as object only you have to initialize the data? How you can tell using this method, okay? This method is like a medium to initialize the data members, that is this non-static variables. Now, here, if you want to initialize only for the S dot student, I mean student object, student S, you can pass the S dot student details. You are just calling it with the help of object reference. Now you want to initialize it. If you want to initialize it using this, I mean, if you want to initialize, you can do without this also. You can do without this also. You can do, but most of the time, what happens? The attributes here, what are the global variables we'll see here? No, the global variables and the local variables will have the same name always. They will have the same name. But to differentiate them, okay, you want to go for your global variables only to initialize. Okay, to get initialized, okay, you want to call this global variables. So that is why, though we have a local variable with the same name, if you're using this keyword, you will be pointing towards this global attribute. You'll be pointing towards this global attribute. Okay. So this is why we'll be not going for yes. I mean, yes, we can't pass here. You can just call it and you can pass data. You can pass the data here and that will be reinitialized to whichever object you want to. Okay. Suppose if it is for the S object, you can call S star students and the data will be initialized. And S1 dot student details, now the data, whatever you have given, it will be initialized. How many ever objects you can create, you can create how many ever you want. Just call student details method with the help of the object reference and you can initialize with the data and the data will be going and initialized to the original attribute of the object. Okay. Now, yes, Varshita, are you still here? Okay, yes, Sanken, did you get it? Okay. Okay, guys. Now what we will do is we have studied about non-static variable, non-static method. Now let us study about non-static initializer. I will just tell you the difference. You will only understand. Very, very easy and very, very simple. So let me tell you the difference between both of them. Okay, so listen carefully. We have both static and non-static initializer. Okay. Under initializers, we have two types. First of all, under initializers, we have two types. Under initializers, we have two types. That is static initializer as well as non-static initializer. Static initializer and non-static initializer. In the static initializer, we have two types again, that is single line and single line static initializer as well as multi-line static initializer. Single line static initializer and multi-line static initializer. So here this is under static. Now coming under non-static here. So under non-static also we have two types. Under non-static also we have two types, that is single line non-static initializer multi-line non-static initializer. Multi-line non-static initializer. Okay. So this is the divisions of your initializers. Initializers means they are used to execute the startup instructions, and we have static initializer as well as a non-static initializer. In the static initializer, we come across single line static initializer as well as a multi-line static initializer. And under non-static initializers also we come across single line non-static initializer as well as multi-line non-static initializer. So this is the tree structure of your initializers. Okay. Next, after this, now let us see the syntax differences of this static and the non-static initializers. Static and non-static initializers. So let us see that. Okay, here only we are. Okay, in the same, okay, let us go for new one. Okay, now let us see the syntactical difference. Okay, syntax difference. First one for single line static initializer. Single line static initializer. Listen carefully, it's very easy. Single line static initializer. Now the syntax is, listen carefully. Syntax is, you need to have a static keyword. You need to have a data type, one variable is equal to value or expression. Semicolon. This is for the single line static initializer. Okay. Now let us go for single line non-static initializer. Single line non-static initializer. Listen carefully. Now the single line non-static initializer is having just a data type. Variable is equal to value or expression. That is the difference. What is the difference between this and this? Now can anyone tell me the difference between this both? Can you tell the difference? Can you tell the difference between this single line static and the single line static and single line non-static initializer? What is one difference here? What is the one difference here? That is static. Keyword. Yes, only static. That's it. Here non-static initializer means it will not have static keyword. Here. Okay. So that's all the difference between your single line static and single line non-static initializers. Next. So we shall go for the multi-line static. That is still easy. You can write it here. It is very, very easy. Okay, let us go for multi-line here. So multi-line static initializer. Okay, multi-line static initializer. So multi-line static initializer, the syntax is just a static keyword and a block. Here you can write the statement or instructions. Okay, now here we have static keyword and here we have the brackets. That's it. Okay, now coming to your multi-line non-static initializer. Multi-line non-static initializer. Multi-line non-static initializer we can go for. Now can you expect what will be the syntax here? Now you guys tell me what will be the syntax of multi-line non-static initializer. Static initializer is static and brackets. Okay, now non-static multi-line non-static initializer. Can you tell me what will be the syntax now? Can you guess it? Yes, without static, that is just the block and the statements, that's it. And I think your counselor is there. Yes, Varshita, are you here? Varshita, are you here? If you are here, you can carry on with the requirements. Guys, we'll resume back after requirement announcement. Yes, Varshita, you can carry on.
Thank you, ma'am. Thank you, ma'am. Good evening, guys. This is Vashita from announcement team. Am I audible to everyone, guys? Okay, guys. Thank you. Thank you, ma'am. Okay. So, guys, here's the development and generic requirement. So, please take a snap of this, everyone. For the development requirement, you have to drop a message to the HR in the QTalk app, your name, contact number, and the company code to Ankita and Havinash. For the generic requirement, for both the testing and development students, both can register. So for the generic requirement, I will be sharing the registration link in the broadcast, guys. You can register through that link. So please take a snap of this, everyone. Is it done, everyone? Shall I stop sharing the screen? So I'll stop sharing the screen now. So guys, make sure that after completing your class, go through once and check it out with the requirement. If you're suitable for this requirements, guys, so please register it. Okay. So any doubts? Okay. So that's it from my end, guys. Thank you, guys. Thank you, ma'am.
Okay, guys. So we'll resume back. So the syntactical difference between this is just a static keyword. That's it. Okay, if you know static in single line and multi-line, you already know non-static single line multi-line. Okay, so this is the difference. Okay, you'll just not write static keyword. Okay, you'll just not write your static keyword. Okay, so this is the syntax of your multi-line non-static initializer. Multi-line non-static initializer. Okay, you'll not write a static keyword. After this, okay, now how the loading process will be there. Okay, how the loading process will be there and what will be the instruction flow, so execution flow, everything we will see. Okay, so here, so the difference here is, let us see some one more difference here. These static initializers, which you are seeing in the LHS side here, these static initializers, they will load and execute during during class loading process. During class loading process from top to bottom order. From top to bottom order. Listen carefully. This static initializers load and execute during the class loading process from top to bottom order. Okay, from top to bottom order during the class loading only, all the static initializers will load into the memory and they will execute. Okay, during class loading only. During class loading only. But what about this non-static initializers? Non-static initializer, they will also load and execute during object loading process during object loading process from top to top to bottom order. From top to bottom order. Okay, so non-static initializers also, they will load and execute during object loading process also from top to bottom order. See, we have seen object loading process into the memory. Just now we have seen into the heap area. We started loading the object with the help of constructor. You created a memory for the object and it called constructor. Constructor loaded all the non-static members into the memory. While loading that non-static members into the memory, it will also load these initializers. It will also load these non-static initializers and they will also be executed from top to bottom order during the object loading process. During object loading process. Okay. So this is also one difference here. Okay. This is also one difference. So initializers in a single word, it's a instructions. Those are used to execute the startup instructions. So here we have single line and a single line static, single line non-static, and multi-line static, multi-line non-static. And here multi-line non-static initializers also, they will load inside method area, and multi-line static as well as multi-line non-static also, they will be loaded inside method area only because they have brackets. Here. Okay. So hope you have understood the difference. That's all is the difference here. Okay. Hope you have understood. Yes. And basically what is heap area? Why it's not considered as a static part? See, why we cannot consider the heap area as a static? Because we have 4 areas. What are those? Method area, where all methods will be stored. Class static area, the name itself is there, static area. All static members will store here. Heap area is for, stack area is for the execution of both static and non-static. This is for execution. Now, okay, methods for both static and non-static, you have variables for the static. Okay, static variables and single line initializers you have. Now, tell me, for non-static, where we have to go? To store non-static members or to go store the instance, where we have to go? We have to go for heap area. We have to go for heap area. Here we'll be storing non-static members. Non-static members, variable, method, initializers, everything will be storing here. Everything will be storing here. Okay. Now, this class static area is for static members. Heap area is for non-static members. Class static area is for static members and non-static, the heap area is for non-static members. So that is the difference here. Okay. That is the difference. Hope you got it. That is why we'll go for the heap area when you want to create an object. Okay. So hope you got it. Yes, Sanket, you got it? Okay, hope everybody has understood. Now what we will do is, yes, okay. So what will we do here is, okay. See, just like always remember, static members, they will load and execute during class loading process only one time. But non-static members, every time we create object, they will, all the non-static members, it doesn't matter if it is a initializer also, all the non-static members will be loaded and executed for every object creation. Okay, for every individual object or for every object creation, okay, all the non-static members will be loaded and they will be executed. Okay, so this is the beauty of your object. And Now let us start with one example of your non-static initializer. Okay, non-static single line and non-static multi-line initializer. So we will start with. Okay, so we will also include static also, non-static also in the upcoming programs. Okay, so don't get confused. Have your mind only on whatever I teach. They later you can ask doubts. Okay, but if it relates to the current concept, we can ask here itself. Okay, so here now let us start creating your, what is this? One second. Okay, now let us start creating a class. Okay, inside that class, we will be having a both multi-line non-static single line, multi-line non-static initializer as well as a single line non-static initializer, both we will have. So let us create one class called as non-static initializer. Okay, it's a big one. So what we'll do, class ABC. So we have a class ABC here. Now inside the class ABC, now first let us go for single line, single line, single line, non-static, non-static initializer. Okay, single line non-static initializer. So we'll go for int a. This is a non-static variable. Int a, int a is a non-static variable. Okay, but int a is equal to, suppose if we go for 5, this is a single line non-static initializer. Single line non-static initializer. So in the same way, we will go for multi-line non-static initializer. Multi-line non-static initializer. We just go for blocks, and here what we will do is we will tell here, that is multi-line non-static initializer. Multi-line non-static initializer. Here we have a single line. Okay, here we have a single line. So we can even print the data here. The variable a you can print. As I told you, you remember non-static context. In a non-static context, multi-line non-static initializer also will be included, as well as your non-static method. Okay, non-static method also will be included. Non-static method also will be included. Okay, so multi-line non-static initializer as well as a non-static method, both will be included in a non-static context. And you already know from the non-static context, okay, for non-static block, you can call the non-static members directly with their names. You can call the non-static members directly with their names here. So that is what we have done. This is a non-static single line initializer. So we are calling it directly with their names. Okay. Now here, and we have also had a line here, that is multi-line non-static initializer. Multi-line non-static initializer. Okay, multi-line. Okay, let it be the whole word. Okay. Now let us go for your main method. Now let us create only one object. Okay, now let us create only one object here. So the object will be for ABC. I is equal to new ABC of no argument constructor. Okay, we have created. We will call no one. We will call nobody here. We will execute only whatever is there. We'll just execute whatever is there here. Now let us start loading this class. Okay, let us start loading this class and understand how the tracing is happening. Okay, how it is executing. So let us understand here. So let us go for your, okay, wherever it is. Okay, differences we have seen now. Okay, this difference is also useful for you. Let me pass one line here. Okay, this difference is also useful. Okay, okay, let it be. You will have a difference. You will remember it. Okay, now let us go for your memory, that is Java runtime environment. And why do we take only white background is because in white background only it will come visible properly. Okay, So first block, that is method area. First memory, that is method area. Next comes class static area. Then comes stack area, and then comes heap area. Stack area and heap area. So here, now let us go for the memory, that is Java runtime memory. Now here, we also have a method, different, parted memories here. So memory names, that is method area, divisions of memory, method area, class static area, stack area, as well as heap area. Someone asked one doubt here. Let me see. Okay, understood, I think. Okay. So here we have the four memories, four divisions of memory we have here. Method area, class static area, stack area, as well as a heap area. Okay, fine. Next, what will happen here? The whole class should get loaded inside. The whole class should get loaded inside the class static area. And the class name is ABC. Class name is ABC. Okay, and we have two blocks. Listen carefully. We have two blocks. One is multi-line non-static initializer. Another one is one static method. Multi-line non-static initializer. Okay, multi-line non-static initializer as well as a main method. Okay, now these are two blocks. Okay, these are the two blocks, and these are both are considered as a methods. Okay, since they have blocks here, okay, now because of the blocks which they are having, they will also, here main method will be taken as a method only, but since it has blocks here and there is a function or some instructions written here inside, so this will also be taken as a method. Okay, it will be considered as a method and it will be written inside a method area. It is not a method, but it is kind of method. It's a initializer, multi-line non-static initializer, single line here, multi-line here. So it is a non-static only, but still it is having a block, so we'll consider this also as a method. Okay, let us load the memory here, load those two blocks here. So from top to bottom you have to load. First one is for your non-static initializer. Next one is for the main method. Okay, next. So address, we'll go for the address, that is 0x1. You already know, since they don't have the name, here you can give dot dot dot. Okay, here you can give dot dot dot. So now what is that instruction we have inside this? That is initializers we have, that is system.out.println of a. Okay, guys, just a minute, I'm getting a call. Excuse me, guys. I just got a call. Excuse me. Okay, so what is the first instruction inside your method? That is, the block. That is system.out.println of A and system.out.println of multi-line non-static initializer. Okay, so these things we have. One we have already loaded. Next one is system.out.println of, can go for multi-line non-static initializer. Now that's it. Now let us go for loading of main method, that is 0x2. Main method signature is main of string array arguments. String array arguments. Okay. Now here in the main method, okay, in the main method, now we shall go for object creation, that is abc I is equal to new abc of no argument constructor. No argument constructor. That's all. Now let us load this block into your class static area. So here we'll have method signature as well as the address. So this is for the static. So here we'll have method signature first. And we'll have address here. We'll have address here. Okay. Now let us load that method here. That is main method. Only static should be loaded here. And this is for main method. So main string array arguments. Address is 0x2. That's all. Now class loading is done. Now your JVM will call main method. JVM will call main method. JVM will call main method. Since the JVM is calling main method starts the execution. Main method starts the execution and one frame will be created for the main method. One frame will be created for main method. Now frame number is F0 and this is for the main method. So main string array arguments. We have one instruction, that is abc I is equal to new abc of no argument constructor. Now here we have a new keyword. So because of new keyword, one memory, okay, one object will be created inside a heap area for the object abc. I mean for the new keyword, one memory will be created and address is 0y1. Now new keyword will call the abc constructor. Now constructor will load the members. So we have one single line non-static initializer. Always remember, initializers also, single line non-static also, multi-line also, they will get loaded and also they will get executed from the top to bottom order. Okay, from top to bottom order, they'll get loaded and executed. Now here we have one single line non-static initializer, that is a is equal to 5. Here by default what happens, here also initially 0 only will be there because non-static initializer is also one variable first of all. So it is a 0, then it will be initialized to 5. Then it will be initialized to 5. Next we have to load this block. We have to load this block here. So let us load that block here. Now one second. Load it with the help of method signature and address. Okay, let us load this with the help of method signature and address here. Method signature and the address. Okay, now method signature, obviously we know it doesn't have any method signature. Address is 0x1. Now single line got initialized, like that multi-line also gets initialized because of the constructor. So constructor will be executing these initializers. Constructor only will be executing these initializers. So the frame number will be F1 and it doesn't have any name. Now the instruction is system.out.println of A. So what is the current value of A here? A is 5. Okay. Current value of A is 5. So here in the output, first you'll be getting 5. Next, after that, we have an instruction that is system.out.println multi-line non-static initializer. Multi-line non-static initializer. So since it is being printed, so we'll write that also. Multi-line non-static initializer. Multi-line non-static initializer. So this is your output. Now, since the frame is done with the execution, so we'll remove the frame and the control now will go back to the calling method. Now ABC constructor work is done. After the constructor work is done, now it will give the control back to the new keyword, and new keyword will store the address or the data inside the variable I. So inside the variable I, now you have the address that is 0y1. You have the address inside the variable I that is 0y1. Okay, now that's it. After that, this memory also will be done with the execution. So we'll remove the frame. Now after that, the whole frame will be removed and will be sent back to the RAM by JRE. Will be sent back to the RAM by JRE, and your output is 5 and multi-line non-static initializer. 5 and multi-line non-static initializer. Okay, now let us execute that. We execute here. You'll be getting same 5 and multi-line non-static initializer. Yes, you are getting this. Okay, so this is how you will load and execute the non-static initializer. You load and execute this non-static. Oh God, 1 second. This is how you load and execute this non-static initializer. Let us take a snap of this. Okay, now let us take a tracing part. Snap of tracing part. Okay, so I hope you guys have understood. Everybody got the concept? Have you guys understood, everyone? Okay, please repeat in Eclipse. Sure. Yes, Preeti, we can do it. Both static, non-static, both we can do in a same program. We can do it. Okay, let me explain you here first. Okay, so here what happens? So we are creating an object here, no? Now new keyword is there. Constructor is called. Now constructor is called. It will load the members. First it will load this variable. While loading only, it will also execute. While loading only, this will also execute. Okay, so value of A is 5. Now while loading only, this will see, it is first one. This is first one. Single line is first one. Then iterate is the second one. So first single line will be executed. Next your multi-line will be executed. So multi-line is executed. The variable A, what you have inside that? 5. Okay, and the 5 will be printed, and your multi-line non-static initializer also will be printed. Now constructor work is done. Okay, it will tell new keyword the work is done, and here inside the variable I, the object address will be stored. Inside the variable I, the object address is stored. Okay, so this is how you will be loading and executing the single line and multi-line non-static initializers. Single line and multi-line non-static initializers. Okay, so 1 second guys, excuse me. Okay, hope you guys have understood. Okay, so did you guys get it? tracing part. Yeah, this is the tracing part only. This is the tracing part. What happened? In this tracing part, what you didn't understand? Yes, Saket, you understood? Okay, so yes, I think you guys understood. See, we can do both static and non-static in the same block. In the means in the same program, we can do both. I'm 0y1 concept. See, this is a address, okay? Just like that, see, for every component, there is one address. For every component in your Java, there is an address because we are storing this in memory, right? Right? We are storing this in memory, okay? In memory only, right? It is stored. Memory will have address, right? This is one address. For this object, one address is there. For this method, one address is there. For this block, also one address is there. So for this also one address is there. Here also for this also one address is there. For this also one address is there. For everything, there is an address. For everything, there is an address, okay? Here we are not mentioning for a class because the class itself is getting loaded directly and the members are being addressed, okay? So everything has an address here, okay? So 0y1 is a address and here, okay, so what you asked, I got it. Now here what happens is, now new keyword, listen carefully, new keyword creates a block of memory for the object. New keyword, then it will call ABC constructor. Then it will call ABC constructor. After that constructor is called, see, when a constructor is called, constructor will load all the members. While loading, first one it will load, that is single line initializer. Single line initializer, during object loading only it will load and execute. So single line initializer gets loaded. Okay, it will first of all non-static members only will be first loaded. While loading only, single line initializer also will execute, as well as your multi-line initializer will get loaded and executed. It will get loaded as well as it will be executed. Since it has been presented inside a method block, okay? Since it has been presented inside a method block, now for execution of that also we need to create one frame. For execution of that also we need to create one frame. So after creating frame, executing everything, a control will go back to the constructor and now it will control will be given to the new keyword, and the new keyword, it will store the address of this object, that is 0y1 into this variable I. It will store 0y1 into this variable I. Into this variable I will store. So this is the process. Okay, got it, Sanket? Okay. Okay, guys. Now what we will do is, let us do one more program, okay, wherein you have both static as well as non-static, okay, both single line static, single line non-static, and both multi-line static, multi-line non-static we will have inside the same program, and now we will execute it, okay? So, okay, what we shall do is, in the same program we will take, now let us take one single line static initializer. Int b is equal to, when static int b is equal to 10. In the same program we are doing, for this separately also we'll be doing a tracing part. This is a, okay, above we will write that this is a single line static initializer. Okay, now we'll go for single line, multi-line static initializer. Multi-line static initializer. Go for a static block. We'll print the variable b. Okay, and we will also tell that this is from multi-line static initializer. Okay, now we have just created an object, that's it. We have just created an object. We will call no one. Because we are dealing with initializers. Okay, we are dealing with initializers here, so we will call no one here. And now let us start loading this whole class inside your memory. Okay, let us start loading them. So we will go for this, and we will take a new one itself. Let us go for the new one. Okay, so let us create one memory here for the, okay, so memory name I will take. You already know this is Java runtime memory. So method names only I'll be taking here below. And we'll have divisions of memory here, that is your first method area, then comes class static area. Okay, the memory size is a bit less. Okay, method area, class static area, stack area and heap area. Stack area and heap area. Okay, so let us write the method divisions here. This is method area. Okay, here you have class static area. Here you have stack area. And here we have heap area. Okay, next. So what we have to do now, first and the foremost things, listen. Now we are having a combination of both static and non-static initializers. So listen carefully. So first and the foremost thing is here the whole class gets loaded. The whole class gets loaded and the name is ABC class. ABC class. Now let us load all the methods here. So first one for single line static initializer. Next one for the, okay, single line will take it. Okay, single line not required. So multi-line static initializer, first one is for, next for, okay, let us take it little elaborated. Okay, multi-line static, multi-line non-static, as well as a main method. So let us go for the addresses here. Address 0x1 single line, I mean multi-line static initializer. So we'll be printing system dot out dot println of b, and we'll be writing, that is system dot out dot println. Here we'll be writing multi-line static initializers. Static initializers. Next, 0x2 will go for one more, that is a multi-line non-static initializers. We'll be printing system dot out dot println of a, and we'll be printing, that is system dot out dot println of multi-line non-static initializer. Next, the static method, that is the main method. So method signature of main is, we shall go for here, main of string array arguments. String array arguments. Okay, next. We have an instruction inside that, that is ABC object creation ABC I is equal to new ABC of no argument constructor. Hope this is going into your mind. How many blocks we have? One static, one non-static multi-line, one static multi-line, one non-static multi-line, and one main method. 3 blocks are the totally. So we have loaded that. We have loaded that here. Next. So here we have to go for one tabular column wherein we will load the members. Only static with the method signature and the address. With the method signature and the address. So we'll write the method signature here. Method signature. And we'll write the address here. Now we'll write, since there's only one static method, that is main method. So I'll write it as a main string array arguments, address is 0x3. Okay, 0x3. So next, now listen carefully. Still we are in class loading only. Still we are in class loading only. Main method we have and one more static method, static block we have. What is that static block here? One more. That is your multi-line static initializer. So that also will be loaded. So address dash dot. So it will also be loaded 0x1. Okay. So from top to bottom it will load. You can load anyhow. Okay. My suggestion is go from top to bottom. Okay. So I have loaded main method first, then the static multi-line initializer. Okay. So here we have loaded that. Now see the code here. Now we loaded. We are still in class loading only. While we are loading only, your single line initializer will execute. Okay, single line static initializer. Now it will execute. So now single line static initializer. Always remember, currently we will be executing static. That means compiler currently it will be executing only static. Only static. Still we are in class loading process only. Now static variable b gets executed. So b initially will be 0 only because it is also variable, right? Then it became initializer. So initially it will be 0 only. Then it got initialized to 10. Okay, later. Now coming from top to bottom order, first one we executed initializer. Now coming here. No, we have one more multi-line initializer we have. Multi-line initializer we are executing. So for the multi-line initializer, now we'll be creating one block because it will execute now, na? So we are creating one block here for that. So the frame number will be F0. This is for your multi-line static initializer. So what are the instructions? System.out.println of b. So current value of b is how much? 10. So you'll be getting the output 10. So one more instruction is there. System.out.println of multi-line static initializers. Okay, so same thing you'll be getting in output also. Okay, you'll be getting as a multi-line static initializers. Okay, next. So execution of the block is done. Now the block will be removed. Because execution is done. Now see, every control will be inside your class only. Whatever blocks we will execute here, okay, control will be inside from the class only because it is written inside class. So control will be inside class only. So next after this, so do we have any more static we have here? No, we don't have any static members here. Now that's it. Now your JVM will call main method. Initializers is done. Now your JVM will call main method. Okay, so when JVM is calling main method, main method will start executing. One block will be created for that main method. And it will start executing. Okay, whenever it start executing, it will start one block will be created for main method. Method signature main string array arguments. And we have one instruction inside that is abc I is equal to new abc of no argument constructor. Okay, next. Listen carefully. Now we have a new keyword. Because of new keyword, now we'll be creating an object for the ABC class. Now we will be creating. So address will be 0y1. Okay. Now after that, new keyword will call ABC of no argument constructor to load and execute the initializers. First of all, to load all the non-static members. Okay. See how many non-static we have. First, coming from top to bottom order. Okay, so we have int a is equal to 5. Okay, int a is equal to 5. Okay, a is equal to 5 is loaded. Int a is equal to 5. Now that 5 will be loaded here. A will be loaded with the initially 0 only because it is also a variable. Okay. Then it will be initialized to 5. Next. Now coming from top to bottom order, one single line is done. Now let us go for multi-line. Okay. It will be taken multi-line. Okay. Multi-line will be taken. So now multi-line will execute. So we will just create a block there with the method signature and address. We need to load it because we already loaded that in method area. With due respect, we'll be loading that here also. So here method signature we need to have it. Method signature. We'll go for address. Okay, now method signature is there. Yes. Now let us load that multi-line non-static initializer. Dot 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 address is 0x2. This block. Okay, address is 0x2. Now after that it will be executed. Loading and executing both will be done during object loading. I already told you because of this ABC constructor. Now it loaded single line. Now multi-line also got loaded and it will be executed now. Because of this constructor only it will be executed now. So here, okay, now we'll be creating a block of memory here. And the address, the frame number will be F1. And this doesn't have any name, so dot dot dot. We have instructions inside that is we'll be printing the value of A. So system.out.println of A. So what is the current value of A here? It is 5. So now we'll be going for 5 here. Now after that one more instruction is there. Okay, one more instruction is there. So we'll go for system.out.println of will be going for multi-line non-static initializer. Multi-line non-static initializer will be executed. So here again you'll be getting multi-line non-static initializer. Multi-line non-static initializers. Okay. Next. So this frame got executed now. So the block will be removed because the execution is done. Okay. Now control goes to the calling block, that is your constructor ABC. Now ABC will return the address to the new keyword because it is done. Loading is done. It will be returning back the address. A new keyword will store the address inside the variable I. So inside the variable I, we have the address 0y1 now. We have the address 0y1 now. Okay. Now anything else is there inside main method to execute? Obviously no. So main method block also will be removed now. Main method block also will be removed now. Now everything has been removed. Now control will be removing the whole memory from the execution and it will be given back to the RAM. And your output will be 10 multi-line static initializers and 5 multi-line non-static initializers. Okay. 10 multi-line static, 5 multi-line non-static. Okay. So let us execute here. Okay, you see the output? 10 multi-line static, 5 multi-line non-static initializers. Okay. So this is how you will be dealing with your both multi-line static and multi-line non-static initializers. Multi-line static and multi-line non-static initializer. Both single and multi-line static and non-static. Let us take a snap of this. Let us take a snap of this also, tracing part. Okay. So hope you all have understood. Everybody understood? Has everyone understood? Why we didn't go for non-static initializers right after static initializers? See, it will not be executed. How can you access a non-static members? How can you access non-static members? Using non-static only. You can access non-static with the help of non-static. With the static, you can't access. Okay, so that is why this is the rule. Okay, this is how it executes. If you ask me why non-static is not executed, means here static members only will be loaded and executed first. Okay, during class loading. Next, by object we can use non-static also. By object we can use non-static only, and by object creation with the help of reference you can use static also. You can use static with the help of a non-static reference. Okay, static also you can use with the help of non-static members. Imagine all the programs in the group also. Yeah, Shivani, sure, I will send you. Every day I'm sending, no. See, Himanshu, is it clear? First, why you didn't go for non-static keys? Right after static. For here it will only first to go for static. Okay. We can use this command now for non-static. Which command? Which one? Himanshu, did you get it? First static only will be loaded and executed during class loading. First class should load, right? While loading only it will execute. Okay, we don't have control over it. Okay, compiler only will do it. But non-static we have control. By creating object only it will be done. So this is about a non-static. Okay. Sanket, by which one? What you're telling? We can use this command now for non-static. Yeah. This, yes, this keyword you can use. It is not a command, it is a keyword. Command is a different word. It's not a command, it's a keyword. Don't go for this practice. Don't go for command, or don't tell like this. This is a keyword. You can tell it as a non-static variable also, but it is a keyword. Yes, you can use this inside them. Okay. This inside the non-static you can use. Okay. So we have used this keyword inside non-static. When you are using this keyword in the previous program, you have used here. In the non-static only, we have used this keyword. Obviously, when you're using inside method, obviously inside a multi-line non-static initializer also. Okay, multi-line inside there, multi-line also you can use this keyword. You can use this keyword, but okay. So here currently we are not using, but if you want to, you can initialize. Okay, if you want to use, you can use it. But in the non-static, you can use this keyword. We will do in the upcoming classes. We will surely do. Okay. After a few classes, we will be going only with the help of dynamic read. Okay. Only by using the dynamic read only we'll be going. Don't worry about that. Understand the concept. When you understood how we are doing it with the help of our own, by giving our own data, you'll easily understand by taking the input from user. You can even try. Even you can try. Don't wait for me. Okay. I'm just covering the portions how much ever you wanted. Okay, you can do wonders with the code. You can take input from user. Try it. Okay, try it. Every day you have one homework. What is the homework? Trace the code, execute the code, trace the code, do everything with the code. Okay, whatever you want to do. And if you have any doubts, you can let me know in the class. Okay, and few people, I mean 2 people have asked for the backup. So backup will be given to you tomorrow at 10 a.m. Okay, tomorrow at 10 a.m. you'll have backup. 10 o'clock to 11 o'clock. Okay, 10 to 11 you'll have a backup. If anybody wants to join in this time for a 3 days backup class, okay, for 3 days backup class you can join. Okay, okay guys, that's it for today. Are you guys clear with the concept? Everyone, is everyone clear with the concept? Okay guys. Okay, I hope everybody is clear. Okay guys, so that's it for today. And yeah, I'll see you. Backup means if people have missed the classes, I'll be revising them. I will be teaching them. Can you give handwritten notes, ma'am, for this topic? See, this loading process is there, no? If you open the PDF which I have sent you, non-static and non-static members PDF, if you open and see there, you will be getting all the details of the class loading process as well as the object loading process. Class loading is already there. In the object loading process, neatly instructions has been given. Okay, everything is in your notes. Go through once. Okay, handwritten notes not needed. Whatever is there in PDF, that is enough. And the same thing is there. Whatever I've told, everything is there in that PDF. Okay. So, okay, guys, that's it for today. And I'll see you guys in tomorrow's class. Have a great evening. Take care. Bye bye. Good night.